Section 3.3, Equation of a Line. You actually have three ways to write an equation of a line. You have slope-intercept form, and slope-intercept form is y equals mx plus b. We've used that before to graph a line. You also have point-slope form, and that's going to be used to write the equation of a line. Y minus y1 equals m parentheses x minus x1. We've also talked about standard form. Standard form is ax plus by equals c. But there are a few restrictions on standard form. First of all, you do not want fractions, so no fractions. The other part with standard form is that the leading coefficient a has to be positive, so you need a to be greater than 0. So make sure when you're talking about standard form you have no fractions and that a is greater than 0. So these are the three ways that we're going to look at to write an equation of a line. Some of y'all have already used slope-intercept before, but I'm going to use point-slope, change it into slope-intercept, and then change it into standard as well. So we're going to look at all three ways. So to write the equation of a line given a point 3, -5 with slope 2. Let's go through the checklist of the things you need if you see the direction to write the equation of a line. The first thing you need is a point. The second thing you will need is a slope. And the third thing you need is decide which form you're going to start with. I'm always going to start with point-slope form. You can decide which method you like better. To write the equation of a line, let's go through the checklist. Do we have a point? Yes. Do we have a slope? Yes. And what form will I use? Y minus y1 equals m parentheses x minus x1. So we'll label our point accordingly. This is x1, this is y1, and my slope is 2. Plugging it in, I end up with a y minus a -5, so we turn out to be a y plus 5. My slope is 2, and I'm going to have x minus 3. If MyMathLab asks for point slope, you are done. This is point slope. Now most likely I would rather you write it in slope-intercept. So we're going to take point slope and change it into slope-intercept. To do so, we'll start off by distributing that 2. So we have y plus 5 is going to equal 2x minus 6. Last step to get y by itself is to subtract over the 5. So y is going to equal 2x minus 11. That is considered slope-intercept. So it's good to know which form you're in and which form you're changing it into. So now we have point slope is in blue, slope-intercept is in green. Let's change slope-intercept into standard. To put it into standard, we need x and y on the same side. So I'll need to subtract over the 2x. I still have plus y equaling -11. Now from the beginning with standard form we said we're not allowed to have that leading coefficient being negative. So I'm going to multiply everything by a -1 to switch my signs. So I'll end up with a 2x minus y equaling positive 11. And that is standard form. So I will always start off in point slope. We'll change it into slope-intercept, and then we'll change that into standard. Make sure you know the different forms. Number 2. Write the equation of a line given 2 points, -3, 6 and 3, -2. So if we go through our checklist, we need a point, we need a slope, and we need the form. Those are the three things we need. Well, do we have a point? Yes, they were generous. They gave us 2 points. But the problem is they didn't give us a slope. So to start this one off, we have to find slope. But we know how to find slope given 2 points. y2 minus y1 over x2 minus x1. So we'll have to do a little bit of work before we can start writing the equation of a line. y2 is -2 minus 6. x2 is 3 minus a -3. So we end up on top with a -8 and on bottom a positive 6. So yes, we might have some fractional slopes that we're going to have to work with. This does reduce, and this reduces to -4/3. So now we have the things necessary to write the equation of a line. We have a point, we have a slope, and the form that I'm always going to use is y minus y1 equals m parentheses x minus x1. I'll start with point slope, I'll change it into slope intercept, and then I'll finish it off with standard. You can decide which point you want to use. I'll just go ahead and use the first one. So there's my x1, y1. Plugging that in, I get y minus 6. My slope is negative 4/3, parentheses x minus a negative 3, so I end up with x plus 3. If MyMathLab asks for point slope, you are done. This is point slope. Now, we'll take point slope and we'll change it into slope intercept. To do so, we'll have to distribute that fraction. Remember, we love multiplying fractions because all we have to do is multiply straight across. So we end up with y minus 6 equaling negative 4 times x is a negative 4x, and 3 times 1 is 3. Negative 4 times 3 is a negative 12, and 3 times 1 is 3. Well, if you look at the last term, negative 12 over 3 reduces. So y minus 6 equals negative 4x over 3 minus 4. To get y by itself, I'll add over the 6, and we'll end up with y equaling negative 4/3 x plus 2. That form is slope intercept. So I'll abbreviate slope intercept, INT. Now, we need to change slope intercept into standard. Well, to change it into standard, we need the x and the y on the same side. So I'll need to add the 4/3 over. So 4/3 x plus y equals 2. Now, looking back at our notes, we're not allowed to have fractions in standard form. So I'll need to multiply both sides by something that will get rid of my fraction. The only denominator is 3, so I'll multiply everything by 3 over 1. When I multiply by 3 but divide by 3, I just get 4x. Now, when I multiply 3 times y, I get 3y. Don't forget you have to multiply 3 times 2, and 3 times 2 is 6. So there's your standard form. So number 3 is going to be the same type of process. You're going to have to find your slope first, then decide which form you're going to start with, which is where I always start with point slope. I'm going to give you the final answers in point slope, slope intercept, and standard, so you can check and make sure your answers are correct. So for point slope, you should end up with y minus 6 equals negative 8 over 11, parentheses, x plus 2. And that's going to be your point slope. To change it into slope intercept, you would then have to distribute that fraction and work from there. For slope intercept, you should be getting y equaling negative 8x over 11 plus 50 over 11. And that's going to be your slope intercept form. Then after slope intercept form, we change it into standard. So changing it into standard, you're going to have to add over the 8x over 11 and then get rid of your fractions. When you do so, standard form should turn out to be 8x plus 11y equals 50. And that's going to be your standard form. So try that problem, see if you get the right answer. So now let's talk about parallel lines and perpendicular lines. Well, parallel lines have the same what? Same slope. So parallel lines have the same slope, but different y-intercepts. So when you look at parallel lines, they will have the same slope, but they're going to intersect at different y-intercepts. So if we want to write the equation of a line passing through 4, negative 1 and parallel to y equaling 2x plus 3, we're going to need to go through the list of the things we need to write an equation of a line. So to write an equation of a line, we need 1, we talked about a point. Number 2, we needed a slope. And number 3, we needed a form. So let's go through and see if we have all this information. Do we have a point? Yes. Do we have a slope? Well, sort of. We know the line we want has to be parallel to y equaling 2x plus 3. So if we know the slope of this line, we would know the slope of the line we'll be using. The slope of this line is 2. So the slope we're going to use is also 2. So we know our slope. And what form do we use? Again, I will start off with point slope. So y minus y1 equals in parentheses x minus x1. Labeling my 4 as x1 and my negative 1 as y1, I turn out with y plus 1. My slope is 2 parentheses x minus x1, which is 4. I'll just go ahead and put it in slope-intercept form and we'll stop there. Distributing the 2, I get y plus 1 equals 2x minus 8. I'm going to subtract over the 1 to get the y by itself. So y is going to equal 2x minus 9. And that is slope-intercept form. Again, with slope-intercept form, our slope is 2, so we're still parallel to that line, but our y-intercepts are different. So if I graph this, I would see that y equaling 2x minus 9 has a slope of 2, but passes through 4, negative 1. So let's look at number 5. Write the equation of a line passing through negative 4, 2, and parallel to 5x minus 2y equaling 8. Going through the list of the things we need a point, got it. Do we have the slope? No, but can we find the slope? Yes, because if we're parallel to 5x minus 2y equaling 8, I just need to find the slope of this line, and I'll use the same slope. Well, to find the slope of a line given an equation, I need to put into slope-intercept form. So I'll subtract over the 5x, so negative 2y equals negative 5x plus 8. I'll divide everything by negative 2, and so y is going to equal 5 halves x minus 4. Reason being is because the negative divided by negative is a positive, so we end up with a positive 5 halves, and 8 divided by negative 2 is negative 4. So we know the slope of this line is 5 halves. That's the slope we will use for our line. So again, we'll start off with y minus y1 equals m parentheses x minus x1. Labeling my point as x1, y1, and I might know that my slope is 5 halves. So y minus 2 equals, my slope was a positive 5 halves, and I get x minus a negative 4, so I end up with x plus 4. Let's go ahead and put that in slope-intercept form. So I'll multiply in the 5. Again, we love multiplying fractions because we could just multiply straight across. So y minus 2 equals 5 times x is 5x, and 2 times 1 is 2. Plus 5 times 4 is 20, and 1 times 2 is 2. So hopefully you'll see that the 20 over 2 can be reduced. So y minus 2 equals 5 halves x plus 10. We'll need to add the 2 over to the other side to put this in slope-intercept form. So y is going to equal 5 halves x plus 12. Slope-intercept form is where I'll stop for that problem. So now let's talk about perpendicular lines. Well, perpendicular lines actually intersect. They're not like parallel lines that don't intersect. However, they intersect at right angles, which means perpendicular lines will have opposite reciprocal slopes. Perpendicular lines will have opposite reciprocal. So let's explain what does it mean to be an opposite reciprocal. If my slope was, say, 2 over 5, so 2/5. The perpendicular symbol is an upside down T. The perpendicular slope would mean flip the 2 over 5, so I get 5 over 2. Since the 2/5 was positive, the 5 halves needs to be negative. So that's what it means to be an opposite reciprocal. Let's try another one. What if my slope was negative 3? Well, the opposite reciprocal, the perpendicular slope, would have to be flip negative 3. Well, it's really negative 3 over 1, so I get 1 over 3. Since the first slope was negative, my perpendicular slope has to be positive. So the perpendicular slope would be a positive 1/3. So number 6, write the equation of a line passing through 2, -1 and perpendicular to y equaling 1/4 x plus 4. Again, to write the equation of a line, what are the things we need? We need a point, we need a slope, and we need a form. Do we have all the information we need? Well, we've got the point. Do we have the slope? Well, not quite yet. We know we want to be perpendicular. So to be perpendicular, we first have to know the slope of the line of the equation that's given. So if I look at this form, it's in slope-intercept, I have the slope is positive 1/4. So my perpendicular slope has to be flipped and opposite. So when I flip 1/4, I get 4, and it needs to be negative because the first slope was positive. So I now have my slope and I have the point from the beginning. So what form do I use? I always start off with y minus y1 equals in parentheses x minus x1. Labeling my point as x1, y1, I'll now substitute in. So I end up with y minus a -1, so y plus 1. My slope turned out to be a -4, parentheses x minus 2. Remember, we have to use a perpendicular slope, so we need to be using a -4. Putting this into slope-intercept form, I'll distribute. So y plus 1 equals -4x plus 8. Getting the y by itself, I'll subtract the 1 over to the other side. So I'll end up with y equaling -4x plus 7. And we'll leave it in slope-intercept form. Number 7. Write the equation of a line passing through -1, -5 and perpendicular to 3x plus 2y equaling 1. So going through the list, do we have a point? Yes. Do we have a slope? Not yet. Do we have the form? Definitely. So how do I find the slope of this line and find the perpendicular slope? I have to put it in the form of y equals mx plus b. So I'll subtract over the 3x. So 2y equals -3x plus 1. I'll divide everything by 2 to get y by itself. So y is going to equal -3x over 2 plus 1/2. So the slope of this line is -3/2, but I want to be perpendicular. So upside down t represents perpendicular. The perpendicular slope would be the flip of that and the opposite. So I take the reciprocal of 3/2, I get 2/3, and instead of being negative, my slope will be positive. So now I will use this slope, 2/3, with this point, -1, -5. So I'll start off with this usual y minus y1 equals in parentheses x minus x1. So I'll end up with y plus 5. My slope was 2/3, and I have x minus a -1, so x plus 1. Distributing my 2/3, again, when I multiply by fractions, I just multiply straight across. So y plus 5 equals 2x over 3 plus 2 over 3. To get y by itself, I'll subtract 5 on the left, so I need to subtract 5 on the right. I do have like terms, but I need to find a common denominator. Common denominator between a 3 and a 1 is a 3. So this needs to be a 3, and this needs to be a 3, with everything else staying the same. So y equals 2x over 3 plus, let's figure out what the numerators are going to be. Since my first denominator had a 3, that numerator won't change, it'll stay a 2. My next denominator went from a 1 to a 3, so I had to multiply by 3, so whatever I do to the bottom, I do to the top. And 5 times 3 is 15. Now I can put like terms together. So I end up with y equaling 2x over 3 minus 13 over 3. And that is considered slope-intercept form. We could put it into standard, but I'll leave that for you to do.